So we have learned about convection as a heat transfer. And so let's remember that is when fluid or air is going to cycle and the hot is going to go up and the cold is more dense and will go down, making that cycle. So we have that convection current, that convection cell happening. So we can see that when we boil water, when we have a hot air balloon, that heat source heats up the air, the cold air comes back down to get heated back up. So that is actually what is happening in our atmosphere all around the earth. So our atmospheric circulation is happening everywhere, all around. So, right, we have our heat source is giving off the heat from the sun, and it's most directed at the equator. We have that direct sun here, and then it's more indirect at the poles. So because of that, right, it's getting heated up. So we know that that hot air wants to rise out away from the earth. So it wants to rise up. So once it gets out a certain ways, it's about, I believe, 17 kilometers away from the atmosphere or away from the earth. Let me see if I can make this a little bit bigger, right? So once it gets kind of out here, it is going to start coming back in. It's kind of blocked by things in the atmosphere. So what it does is it starts to travel out this way. So in both directions, it's going to start, it hits kind of this atmosphere and it's going to start going this way. And as it's doing that, it's starting to cool down. So that hot air, so it's still hot, right? It's rising and it's going to start going this way. And it will also start going this way. And as it does that though, right, it's cooling off because it's getting farther away from that heat source. And once it gets to about 30 degrees in latitude north and south of the equator, it's cooled off enough that it is dense enough that it will start to sink. So that hot air is going out towards the poles. So it goes up into the atmosphere and then it goes out towards the poles. And then it starts to get cold and it comes back towards the equator. So, right, it's getting colder here. So it's denser and coming back to the poles. As it's traveling towards that equator, sorry, I just said poles. It's traveling back towards the equator. As it's traveling there, right, it's starting to heat up because it's getting closer to that direct sunlight. So it's making these convection cycles. So if we turn it sideways, we can see it's going up and down, up and down. So our hot air is going up and out to the poles, and then the cold air is going to sink and go back to the equator. Now I'm going to flip pages for just a second. So we have these cells that happen around the equator, and it just can't quite get up high enough because that starts to get cold enough right there that it comes back down. So I'm going to switch over pages here and see if this is going to, there we go. It's just kind of slow. Okay, so we need to think of these cells as these gears. So I can see that this cell, this gear is turning in that direction. And as it does that, there we go. Right? It makes that blue one turn in the opposite direction. Sorry, it's very slow, so you should really be able to see which way they're spinning. And then, and then that blue one, again, is then turning that red one. Can't see that red marker. It's turning that red one down that way. So, they're working together, going opposite directions. So you can kind of see those spinning there. So that is what is going to happen actually in these cells here. So we have in our next cell up, this air was coming down, it's going down that way. So that means in this cell, it's got to do the same thing, and that means it has to travel in the opposite direction. So we're going to have let's see. So we're going to have our cycle that is going to have warm air going up, and then it goes out, and then it gets cold enough that it's going to come back and meet up with this and sink back in. So, right, this air that's at the equator doesn't just have to stay in that cycle, right? It can get into this one and eventually come into this cycle, and then it could go up here as well. So this cycle actually goes backwards like a gear. So this one went this way, so this one has to go the opposite direction, right? It went this way to meet into that one. So coming the opposite direction here, so this one was coming down, so that means we want our air to be flowing that way. So then it's going to come, and the hot air goes towards the poles, and it goes out, and then it gets cold enough that it comes back together, and it goes in that flowing direction, right? These should meet up and go in that same direction. When they meet up together, they're going that same way. So then the same thing happens there at the poles. So right now this is going up, so this air came and goes up, and it's cycling up just like it was from the equator, and it goes up towards the pole, and then it gets cold at the pole and is going to come back down and meet up here and follow that cycle there. So it's going in that direction and doing the opposite down here at the South Pole. So if I look here, I can see, right, it's going up, so it would follow that up towards the pole, and then it gets dense and comes back towards the equator, and it would meet up with that cycle there. So it's those gears going opposite ways. So if I think of this, right, as, let's see, let's maybe call like this one our equator, right? It goes up and then back down. So hot and then cold back down. So then this one's coming the opposite way. It's going hot up, cold back down, hot up, cold back down. And this one's going the other way, hot up, cold back down. So they're just, every time I'm just flipping the way that I draw the circle. So there is that. So these actually have a name. So these two right around the equator are called Hadley cells. And that's just who first discovered them, was somebody named Hadley. Then we've got right here the Farrell cells, and then up by the polar caps, those ones are easy to remember, the polar cells. So it's just these convection cells of air that have been created because the heat rises and then it gets dense and comes back down once it's cold enough, and it does these in these cycles because of the direct and indirect heat, right? There's less heat up here, so it can't just travel all the way up because there's not the same amount of heat throughout the entire Earth atmosphere. So one last thing I want to show you. So these cells aren't just like right stuck on the edge. So I was drawing them 2D. So they're actually 3-dimensional. They wrap all the way around the Earth. So if you picture the Earth, right, it's kind of this little band that goes all the way around it. So you can picture this Hadley cells connected. So it has our equator is here, right? So we're going up, the hot air goes up, comes back down, gets hotter again, hot goes up, gets cold and comes back down. And here the hot air is coming up and then comes back down. So they meet in together, and then this one, right, comes the opposite way because they want to flow in together. So you can see this arrow and this arrow are going to go in that same direction. So they're actually like these 3D bands that go all the way around the Earth. So it's happening in 6 sections on the Earth. So if we look back here, right, so I have my equator, then I have my 2 Hadley cells, 2 Farrell cells, and 2 polar cells. So we have 6 cells of convection that are happening in the atmosphere.